Today I'm going to show how to run and compare various machine learning models using SAS Enterprise Miner. Let's get started. First, let's look at the dataset. So I've taken the dataset from the UCI Machine Learning Repository. It's a bank marketing dataset which is related with the direct marketing campaign or the telemarketing campaign of a Portuguese-based banking institution. Here our goal is to predict whether the client will subscribe to a term deposit or not. So let's look at the dataset. So we have 17 attributes such as the age, job, these are the details of the client, and then we have some details of the telemarketing campaign such as the duration of the call, the day of the week of the call, the month, and how the client was contacted, and so on. Then this is the output variable or the target variable. So this is a binary variable, let's say either yes or no, that is whether the client is subscribed to a term deposit or not. Now let's head on to the SAS Enterprise Miner. So here, this is first we have to import our CSV file. So we have to just click on import file, then import the CSV file. Now let's look at the variables. Click on edit variables. So here we have to set y to target variable because this is our output variable, which is either yes or no. The others are all the input variables. And we click on OK. First, let's look at the stat explorer to understand which are the most significant variables. So as you can see that the duration has the highest variable worth. So this means that the higher the duration of the telemarketing call, so that means the higher the chances of the person subscribing. So this just really makes sense because the more the person is interested in talking, that means that he is really interested in subscribing. Now let's look at the other blocks. Graph export, we can see the distribution of the output variable. Go to results. So we can see that the output variable is skewed. So there are a lot of no's and there are very less yeses. Okay. So now let's look at the multiplot to understand the distribution of the variables of the independent variables with the output variable. So here we can do some exploratory data analysis to just understand the distribution of variables here. So here we can see the distribution of age by, so you can understand the different age groups and whether they subscribe or not. So as you can see at 31, at the age of 31 there's a higher proportion of people who subscribe, and even at the age of around 34. So 31 and 34 is the correct age of people to target, because we can see from here that the proportion, that is the orange bar, which is kind of higher. Then next we go to the data partition. In data partition we split our dataset into training, validation and test. So we have allotted 50% of our data to training, 30% to validation and 20% to test. There is no hard and fast rule for this, but this is how we take it. Then comes the control point. In the control point, we split the node into various nodes such as the decision tree, the gradient boosting and the neural network. So here we can run various models and then we can select which one is the best one. So this comes to, we come to a first concept of data science, that is the power of experimentation and evaluation. So in data science it's always important to experiment various models and then choose the best model. So here we select the decision tree entropy model. Now let's see. So here we can see that this is the decision tree entropy and this is the decision tree Gini. So the decision tree entropy one has a lesser misclassification rate. So first of all, uh, why decision tree? So we can see that as we've seen in the graph explore node, the output variable is highly skewed. So in such cases, we go for decision trees. And in decision tree, what is the entropy based and what is the Gini based? So entropy based is the decision tree which is based on homogeneity. So if the data is highly homogeneous, then the entropy index is zero. So entropy is a measure of disorder. And coming to Gini, so according to Gini index, so when you take when you take two uh, items from the population, so this is actually a measure of purity. So we understand what is the probability of them to be the same. The next comes gradient boosting block. So what is gradient boosting? So gradient boosting is an ensemble based method where we build strong learning models from weak learners. So what are these weak learners? Weak learners are basic decision trees. So we built advanced models from basic decision trees. So what exactly happens here is it's an additive based model based on optimizing the error function, and we build a higher model, uh, more advanced models of adaptation trees. The next is a neural network node. So here we've chosen various parameters. We can choose the neural network from here, from network. So the architecture we have chosen is a multi-layer perceptron. So this is the most common architecture for neural networks. And then we have chosen three hidden units. So we can optimize all of this. The next is the optimization. In optimization, we have chosen the most common algorithm in neural networks as a backpropagation algorithm. So what exactly is a backpropagation algorithm? So in backpropagation algorithm, what happens is the weights are optimal. Once the neural network is the feed-forward neural network runs according to a given set of weights, then we compute the error function and the output, and then after computing the error function and the expected output, so from the expected output and the output which we get, we go back and we modify the weights so as to so as to reduce the error function. And this is an iterative uh, process where we identify the output, and then we compare it with the expected output. We get the error function, and then we go back and then we change the weights. So now from these two models, we found out that entropy one is better. So we now compare the entropy one, the gradient boosting, and the neural networks to understand which one is the better one. Yeah, click results. So as you can see that the misclassification rate for the decision tree is still better than the neural networks and the gradient boosting. Now let's look at the output file here. So here we can look at the uh, confusion matrix, that is false negatives are the ones which have been classified falsely as negative. The true negative are the ones which have been correctly classified as negative. The false positives are the ones which are being falsely classified as positive, and the true positives are the ones which are being correctly classified as positive. So now we go on to this fit statistics to understand the fit of the model. So the valid misclassification rate, this one is the least for the decision trees. Then you can see that the average squared error is also lesser for the decision tree, but the average squared error in the validation data set is slightly higher. But then finally, when we compare all these models, it's better to choose the decision tree one, as the decision tree one is a simpler model and it's a highly explainable model. You can also see from the lift curve, cumulative lift curve, that the decision tree entropy model is performing better. Here we have a very skewed output, so the best model here would be the decision tree, as it's also simple and also highly explainable compared to an ensembler model or the neural network. And the neural network is time taking as well to run in bigger data sets. So that's it. Thank you.